So consider a roller coaster with a lift hill of height 25 metres, that's here, and a loop height of 18 metres as shown in the figure below. At the top of the lift hill, the roller coaster car has 0 velocity, then it begins to roll down the hill. Calculate the speed of the car at point P on the loop when the car is 6 metres above the ground. Assume friction is negligible. Okay, so first thing we want to do, we mentioned before that our mechanical energy is constant. Let's work out what it is at the start. Okay, so at the start of our problem, our mechanical energy is kinetic energy plus gravitational potential energy. At the start of the problem, what's our kinetic energy? 0. Our cart's not moving. Our gravitational potential energy is going to be mgh. We don't have m. Okay, let's get it in terms of m. Okay, if you're not given m, don't panic. Get it in terms of m, and it's going to be it'll be really impressive to your examiners. Times 25. So you should get 245 m. Okay, we don't know what m is, so our mechanical energy at the start is 245 m. So we want to find our kinetic energy at the end. And so again, our mechanical energy will be constant. So, actually, let's get rid of this. If our mechanical energy is constant, then we know that this 245 m at the end is going to be made up of our kinetic energy plus our potential energy. Okay? So if our mechanical energy is 245 m at the start, it'll be 245 m at the end. All right, let's expand this. 245 m, and you're going to see why this is a bit cute in a second. Kinetic energy is a half mv squared. They cancel. Our potential energy is mgh. Look at that, our m's cancel. We don't need the mass. We can cancel our m's totally. Don't need it. Okay, so 245 is equal to 1/2 v squared plus gh. So g is 9.8. What's h? Okay, I heard 19. That's not a bad guess. That's one way you can do it. But if we're doing it in this particular way, we need this 6. Okay? Because what we're doing is we're measuring the gravitational potential energy at this point. So at this point, its height is 6. Now, if you wanted to work out the change in gravitational potential energy and convert that to kinetic energy, you could do it that way. And then you could use the difference between those and get the 19. I might show you how to do that in a second, actually. But this is one way to do it. So we're looking at absolutes here. So it started at 25 meters above the ground. It's now 6 meters above the ground. Okay. So what's 9.8 times 6? So 58.8. 245 minus that. So I get 186.2 equals half v squared. This is getting a little bit messy. So v is going to be equal to the square root of 372.4, which will be 19.9, also 19.3. Yeah, 19.3 meters per second is pretty quick. Okay, the higher it goes though, the more it's going to slow down. You just want it to be fast enough that it stays in contact with the rails there. Okay, so this is one way to do it. The other way to do it, which is where that 19 comes in, I'm not sure the best way to do it. You might confuse yourself either way. But our change in gravitational potential energy will be equal to our change in kinetic energy. Okay? So, by the way, this side of the problem, this right-hand side, this is done now. I'm just going back to the start and doing it a different way. So whatever gets changed from our gravitational potential energy, that is going to change into kinetic energy. All right, our kinetic energy started at 0, so anything we change in our gravitational potential becomes kinetic. All right, so again, we can look at this and straight away cancel out our H's. Our M's. So G times the change in H is going to be equal to the change in 1/2 V squared. Okay, again, our M's cancel. All right, so this is where our change in height, we've gone from 25 to 6, so we've gone to 19. So 9.8 times 19. A different way. Just solving it a different way. So that's our change in gravitational energy. Our change in kinetic, we need to find V squared. So if you work this all out, we should get the same thing. 9.8 times, if we don't get the same thing, I'll feel really embarrassed. Times 2. And yeah, we will. We'll get V is equal to the square root of 372.4. which is exactly what we got over the other side down here. Oops. There. So, you can either work with the change in height, or you can work with the absolute height, but don't change halfway through. Okay? I actually think this way is probably, you're going to be less likely to make mistakes if you do the way on the right. Okay? Take your kinetic energy before the problem starts, and then take it after the problem starts.